bad. I'm sweating a little less now because it was insanely hot in this room. But this is Cody. I've been very fortunate to have him as a student. Guess you could go hype him up. Blessed to have him as a student because he's overall brings great energy to the classroom. He's great to his peers. He even helps others out, even if their projects are in a different scope than his, as long as he has the know-how how to. And yeah, he's a very efficient worker as well, which I was very impressed by. I won't give too many spoilers on this project, but one modification he made was easily an intensive project in and of itself. And I remember giving this project kit to him, and he had finished it within the next day. Super shocked, and he even continued to add on more and more difficult modifications. But that's all you.
Hi, I'm Cody. I go to Luis Miguel High School in Orange County, and my project is a hexapod with an arm attachment on top. So, as a beginner to engineering, robotics, and electronics, I wanted to find a project that was challenging enough for me to really push myself and learn, but not so challenging where I couldn't build my project on my own and without excessive help. So that's why I chose the hexapod as my project. It also seemed like the most fun build to have after it was fully assembled. So I started my project initially with the hexapod itself. It works with a central control board down at the bottom, connected to 18 different servos, and I can control it wirelessly with this remote here, with this joystick module here, and 3 switches. So if I activate the first switch, I can move it without turning it. The second switch allows me to move just its body. Third, allows me to tilt its body. And if I switch on numbers 1 and 2, I can move and turn at the same time. Lastly, this knob here controls the height of the hexapod. So if I turn it, it will raise it, and I can also have it walk at this height. So after I was done building my hexapod, I decided to add an arm attachment on top. It works with an Arduino Nano wired to 4 different servos and an HM10 Bluetooth module down here, which allows me to control it wirelessly through my phone here. So in this text box, I can input a letter, which will tell it to do a specific command. For example, R will turn it right, L left, Q will bring the first segment down, A will bring it back up, W will move the second arm segment down, S will move back up, and finally C will close the claw, and O will open the claw. And so after I was done building my arm, I decided to 3D print some modifications. The first was this battery pack holder in the back, so the batteries would not just be detached from the build. My second was this front support here to help with the overhang of my arm. And lastly, I decided to 3D print some arm extensions because the acrylic pieces it came with were not long enough when the arm was elevated off the floor. So, however, after I designed and 3D printed these parts, I found out that the dimensions were actually too well fit for each piece, and so I had to file down each part so it would fit with my build. And this is because the 3D printer isn't exact, and the parts are just too small. So instead, I should have given tolerance to the 3D printer by dimensioning it one size too big or too small. Another challenge I had was integrating the Bluetooth to work with my Arduino Nano. Normally, it is controlled by this joystick controller right here, as you can see. But I wanted it to work wirelessly, so I had to rewrite my code so it would work with the Bluetooth module and the Bluetooth signals coming from my phone. So during my time here at Bluestamp, I learned the basics of code, part assembly, part design, and robotics in general. But I think the most valuable thing I learned here at Bluestamp was troubleshooting on my own. The instructors are here to help, but only when absolutely necessary. So solving my problems on my own allowed me to grow more than if Terry just spoon-fed everything towards me. And so I hope to continue this growth by making a wireless controller for the arm, like this hexapod controller, and combine the two. With that, thank you for listening. That was my presentation. And do we have any questions? Yes.
Did you say you have 18 servos today?
Yes. For the hexapod alone, which is the bottom part, there are 3 servers per leg and 6 legs, so 18 different servos. I don't know if you can see here, but the bottom, these are everything that's attached to the bottom Arduino. So, yes.
Was it a challenge to coordinate those?
Yes.
Or do that?
That was another challenge of mine because it's very repetitive and tedious for each servo to be wired and connected to the part. So it was very difficult to get all of that working together. So yes. Any other questions? Yes.
Is Arduino like in your Bluetooth controller? Like, is it in your,
This
no,
one.
no, is your Arduino like in your remote?
For this, yes, there is another Arduino here with an Arduino shield. Yeah. This module right here, I don't know if you can see, it's kind of tiny. There's another identical one under here connected to the hexapod, so that's what allows the wireless control. Yes.
If you were to start this program again from the very beginning, what would you do differently?
If I were to start again, first I would choose a different project. But other than that, I would do more research, so I'm not going into this blind and work on my own time how in sort of YouTube videos like how to code and stuff. So I wouldn't need to ask for help that often. Yes.
What project would you want to do instead?
I think the ball tracking robot was very nice, and I like how it uses this sensor to detect and add a camera. And I might even want to add that to my own project, so it could walk up to something and